Hi, I'm Marcy Cohen. I'm a photographer based in New York, and I'm very happy to be working here with Sujata, who's a oceanographer, and I'm going to let her introduce herself. But we had a great work together on this project for Synergy. It's called Oceans of Time, and I will let Sujata tell you a little about the science, and then I'll tell you a little bit about the art.
So hi everyone, I'm Sujata Murty. I am currently an assistant professor at the University at Albany, so SUNY Albany. I'm also an adjunct scientist here at the Woods Hole Oceanographic Institution, where we're standing now. So my research is all about trying to use corals and models to look at how climate has changed in the past so that we can better understand how it might change into the future. So looking at changes in temperature and rainfall and ocean circulation over the past few hundred years. And I do that using corals as kind of an archive or a recorder of past changes in climate. And so a lot of our work has been thinking about ways to kind of connect this concept of time throughout, that's evident in my research, and connect that with Marcy's great photography. So I'll let her kind of talk about the art side of this.
Right, so this was a great project for me to work with because, well, in college I studied a lot of different things, including geology, and so I've always been fascinated by, the historical, deep history that we have in the earth and the ocean. So it was a great opportunity to combine that, and for some reason my photography has also been based on layers concepts of time and the passage of time and the collision of past and time, how the past influences the future. And in Sujata's work, she's studying the past through the corals to learn more about today and the future and help us combat climate change. So I think it's a great project, and what we're trying to do in the art is to get the message out to the public, because the public generally has a very dystopian view on things, that it's a disaster and the world's going to end. And what we'd like to say is that through the intervention of science and art, we can prevent that. We both feel that is quite possible. So in the photographs that we've put together for the first show, let's say, that we've had, we took photos from Sujata's dives. So we've taken photographs that display the corals, that display under the ocean, and combined it with elements that reflect the passage of time. And we think it was quite successful. So we'd like to move on, and we'd like this to continue and be a long-term project. So we're getting into the next phase, and we thought for that it would be great to come to Woods Hole and just examine, so I could examine firsthand the lab, the corals, the samples, and see where that goes. We're not exactly sure where it's going to go, but I think we've got a very good start.
Yeah, and I think, holding the samples in your hand and seeing what they look like, feeling what they look like, I think that's an important part of understanding, how do we actually do what we do? How do you take something like this and turn it into climate information? So it's great to have you here to show you the cores, to show you the lab. It's been a lot of fun.
Yeah, no, very inspiring. It was great working with you on this project remotely, but to see you here in the core repository is amazing, fantastic. So what is this?
Yeah, so
tell us about this.
We are looking at a piece of coral core. This is the very top piece. So in my research, what we do is we go out into the ocean and we're looking for these huge boulder colonies that can be as tall as the height of this room, so meters and meters tall. And we go out and we bring an underwater drill and we drill a cylindrical core through the middle of the coral. So we're holding one half of that core. This is the top piece, so you can see the coral tissue on the top, and then you just see its skeleton down here, this white skeleton, just calcium carbonate, and this is what we use to look at changes through time using corals.
Right, so I see these bands here. 1, 2, 3, 4, 5, 6. So it's about 6 years?
Yeah, eyeballing it, I think that's pretty much right on. So yeah, in this one it's really nice. You can kind of see some of those bands pretty clearly. Sometimes you can and sometimes you can't. So when we can't, we take a piece, kind of a thinner piece like you're holding, and we x-ray it and take it to the hospital, and I x-ray it like you would a forearm if you broke your arm, I guess. And that will really clearly show us that banding pattern. And so
why are some like closer together than others?
So that would be a change in how fast the coral was growing, between years. So if the coral had a really good year and was growing fast one year, they might have a wider band. If they struggled to grow that year, they might have a thinner band. The other thing to know about a coral is they're a lot like tree rings. They grow these annual bands of density that we can use to, a lot like tree rings, count back in time. One band after another, just like you would with a tree ring, count all the rings and know how old the coral is. So we can actually come down to this point here, say we know, what month and year the coral was growing, this part of skeleton right here, this part of coral. We can measure it, we can look at the chemistry, we can compare that to the chemistry in other parts of the coral and start to pull together a record of changes in the chemistry through time and therefore changes in climate through time.
It's fascinating.
Yeah.